Question 17. Find the vertical asymptote of the rational function fx equals to the x plus 1 over x minus 2. Okay, first step, before you find the vertical asymptote of the rational function, first you let the denominator of the rational function x minus 2 here equal to the 0 and find the value of x. So x here equals 2 and find the infinite limit of the function from the left and from the right of the fx. So first you draw the number line here. So the value of x here equals 2, and first find the infinite limits from the left of the function. So from the negative infinity to the x equals 2. So the first value here, the nearest value from the left, 1.9. Okay, and this value 1.9 substitute into the function. Okay, so substitute into the function x plus 1 over x minus 2. Okay, and answer here from the left of the function. So answer equals to the negative 29. Yeah, negative 29. And then the sign of the infinite limit here equals to the negative. Okay, so here from the left of the function, limits of x plus 1 over x minus 2 here equals to the negative infinity. Okay, this one from the left of the function. And from the right of the function, the value of x here equals to the 2.1, the nearest value. Yeah, 2.1, and substitute into the function, and then find the sign of the infinite limit. So answer u here equals to the 31, positive 31. Yeah, so here positive. So the sign of the infinite limit here equals to the positive infinity. Yeah. So from the left of the function, here equals to the negative infinity, and then from the right of the function here, limit as x approaches 2 of x plus 1 over x minus 2 equals to the positive infinity. And then conclusion, x equals 2 is a vertical asymptote of the rational function. Yeah. Okay, here first step to find the vertical asymptote of the rational function. First method. Okay, and the second method to find the vertical asymptote. Okay, so second method here using the tables. Okay, second method using tables. So first you set the denominator of the function here equal to 0 and find the value of x. So x minus 2 equal to 0 and the x here equals 2. Yeah. Okay, so from the left of the function, so the nearest value of the value of x here equals to the 1.9. So this one, the value of x equals 2. So start from here, from the left of the function. So the first value here 1.9, the nearest value, and the second value here 1.99, and the nearest value 1.999. Yeah, and substitute this value into the function, and the first value here equals to the negative 29, and here negative 209, and here equals to the negative 299. Yeah. And then fx here decrease to the negative infinity, and the limits as x here approaches 2 from the left of the function, x plus 1 over x minus 2 here equals to the negative infinity. Okay, and from the right of the function, so the value of x here equals 2. Okay, so at least 3 value from the right of the function. First value here 2.1, and here 2.01, and here equals to the 2.001. Yeah, and substitute into the function. From the right of the function, fx here equals to the 31, 301, and here 3001. Yeah, so fx here decrease to the negative infinity, increase to the positive infinity, and write down the limits as x approaches 2 from the right of the x plus 1 over x minus 2, and answer you here equals to the positive infinity. Yeah, and then x equals to is a vertical asymptote of the rational function. Question 18. Find the horizontal of the following function. Fx here equals to the x plus 3. Okay, first method to find the horizontal asymptote. Okay, first using the limits at infinity, find the horizontal asymptote of the rational function. Okay, first step here determines the highest power of the denominator, HPD. The highest power of the denominator here equals to the x. Okay, so first step, divide both numerator and denominator by the HPD divided by x. So x here divided by 8x, and x plus 3 divided by x. Yeah. Okay, so numerator 8 over x, and the denominator here x over x equals to the 1. Okay, and plus 3 over x. Yeah, and here you substitute infinity into the function. So here 8 over infinity, and 1 plus 3 over infinity. Okay, so 8 over infinity here equal to 0, and then 1 plus 3 over infinity here equal to 0, and the limit as x approaches positive infinity of fx equal to the 0. Yeah. And second, find the limit of fx as x here approaches negative infinity. So here the highest power of the denominator. So the HPD here equals to the x. Okay. And write down the limit as x approaches negative infinity of x over x plus 3, and here divided by x. Yeah. So 8 over x, and denominator here x over x plus 3 over x, and then here you substitute infinity into the function. Okay, and answer you here 0 over 1 plus 0, and the limit as x approaches negative infinity of fx here equals to the 0. Okay, so y equal to 0 is a horizontal asymptote of the rational function. Okay, question 19. Find the horizontal asymptote of the function fx here equals to the 4 over x squared minus 1. Okay, first method to find the horizontal asymptote of the rational function. So method here using limits at infinity. Okay, first find the limits at infinity. Limit at x approaches positive infinity of 4 over x squared minus 1. So the highest power of the denominator here equals to the x squared. Okay, and here 4 divided by x squared, and denominator here divided by x squared. So 4 over x squared over x squared over x squared here equals to the 1, and minus 1 over x squared. Yeah. So here you substitute infinity into the function. So 4 over infinity square, and then here 1 over x infinity square. Yeah. So numerator of the function here equal to 0, and denominator here equals to the 1 minus 0, and answer here equal to the 0. Okay. So the limit as x here approaches positive infinity of fx equals to the 0. And second, find the limit as x approaches negative infinity of 4 over x squared minus 1. So first here you check the HPD, the highest degree of the denominator. Okay, so here equals to the x squared, and then 4 divided by x squared, and then x squared minus 1 divided by x squared. Yeah, and here denominator equals to the 1. Okay, minus 1 over x squared, and numerator here 4 over x squared. So here you substitute 4 over infinity square, and this one 1 minus 1 over infinity square. So here is a negative. Okay, so answer you here 0 over 1, and answer u equal to the 0. So limit as x approaches negative infinity of fx here equal to the 0. And conclusion, y equal to 0 is a horizontal asymptote of the rational function.